You think an RFID tag cannot be read because the tag is defective? In many cases, the real problem is not the tag itself, but the materials around it. Some materials reflect RFID signals, some absorb them, and some weaken them without blocking them completely. In this video, we will show you exactly what materials block RFID signals and why. At its core, RFID works through electromagnetic communication. A reader sends out a signal. The tag receives energy and then sends data back. But once electromagnetic waves encounter different materials, the way they travel changes. Different RFID frequencies also react differently to surrounding materials. First, let us look at the most typical material, metal. Metal strongly reflects electromagnetic waves, making it one of the most common and powerful sources of RFID interference. That is why ordinary RFID tags often fail when placed directly on metal surfaces. This is also the basic principle behind RFID blocking sleeves. Now, let us look at water. Water absorbs RFID signals, and this effect is especially noticeable in UHF systems. That is why liquid products, humid environments, and moisture-rich items are often harder to track reliably. The same RFID setup may work well on dry packaging, but struggle around beverages, food products, or wet conditions. Concrete can also interfere with RFID performance. It can absorb and weaken signals on its own, and when reinforced with steel bars or other metal structures, the interference becomes even stronger. In warehouses, parking garages, and underground spaces, RFID can still work, but it depends much more on proper reader placement and system design. Besides metal and water, some other materials can also reduce RFID performance. Carbon-based materials may absorb electromagnetic energy. Thick glass and ceramic may not block RFID completely, but they can shorten read range and reduce stability. In many cases, the system does not fail entirely. It simply becomes less reliable. If metal is a common interference source, then a Faraday cage is a more complete shielding solution. It uses conductive material to form an enclosure that blocks external electromagnetic signals. Many RFID blocking products are built on this exact principle. Some materials do not block RFID completely, but they do weaken the signal. Plastic, rubber, and foam often create a different kind of problem. The issue is not total failure, but inconsistent performance. That can be harder to troubleshoot because the problem appears only some of the time. Here is the key point. The question is not which RFID technology is more advanced, but which one is better suited to your environment. Low-frequency RFID is usually less affected by water and moisture, while UHF offers longer read range and faster reading speed. The right choice depends on the materials surrounding your application. If RFID signals are being disrupted by materials, there are usually 4 ways to improve performance. First, choose tags and readers that better match the environment. Second, optimize reader placement. Third, add isolation structures or signal enhancement where needed. Fourth, choose the RFID frequency that best fits the real operating conditions. Whether RFID works reliably depends not only on the tag itself, but also on the materials around it. Metal reflects signals. Water absorbs them. Concrete and carbon-based materials interfere with them. And even plastic, rubber, and foam can reduce performance. If you want RFID to work well, start by understanding the materials in the environment and then build the right solution around them. Thank you for watching. Don't forget to subscribe to our channel for more insights into RFID technology. See you next time.